what's going on. This motor turns this cog. This cog has a point in it, which this slots into and rides on, much like the piston in a steam engine turning the wheel. This striker is on some sprung steel, meaning that when it goes up here, this carries on forward as this motor is inducing a force which then makes it spring up like this. This is limited in its travel by this piece of rigid steel secured by these two bolts. That's where it hits the gong. It then moves down, and then it only moves down this far because again it's limited by the rigid piece of plastic underneath here. And it moves up and down in this way. The motor therefore has to turn a specific amount of RPM in order to turn this cog a specific amount of RPM in order to maximize this multiplication of motion. Too little volts, or, well, basically not enough electricity coming in, means that you don't have this striking as much, or you do have this striking but it's not striking with enough force, and so the tone is weak, the bell is not very loud. Too much, and then the resonant frequency of this is basically overcome, and so more or less the striker assembly actually stays in the middle while this actually flies around it. So it's basically the inverse of what is supposed to be happening. The way to correct this effectively is to use a string of diodes like this, which will therefore reduce the volts, and now we'll show how this does. We have our multimeter set to volts DC, we have the black to the negative, and then the red is the positive. So we connect it up to the battery terminals here. We get 13.28 volts, 13.27 volts. Across the first diode, which is, remember, in series, we have 12.99. The second diode, we have 12.7. The third diode, we have 12.42. The fourth diode, we have 12.41. So I have a feeling that that one is open circuit. The fifth diode, we have 12.12. And the sixth, we have 11.79. And this reduction of 2 volts effectively, well, 1 point something of course, tunes the motor to turn the correct RPM and therefore strike the bell consistently every time. And now we'll see that happening.